This is a reaction wheel. This is a guided rocket, and this is my plan to go from here to there. My name is Sydney Chukwuka. Earlier this year, I built and launched a small model rocket, my first in a long time. After that, I built a powerful high-power rocket and earned my level 1 certification. As cool as that was, it was not good enough. I want to be one of the greats, and that demands achievements and results. I planned for this project to address two mistakes I made in my last two launches. On my last project, I didn't take stability into account on my rocket, and it nearly resulted in a very unstable flight. But I was able to finagle together a solution, and that corrected that problem. I also planned to establish pre-checks. My taser rocket got destroyed because I didn't have them, so I want to avoid that this time around. I really just want to be more methodical, which is why I created this plan. So how do you build a guided rocket? Well, it's going to be an order of magnitude harder than a level 1 rocket I just built. It's also going to be a lot more pricier, around $1,000 it's looking like. But if I'm able to get it done, then I'll be able to take a significant step towards becoming a better engineer and rocketeer. And I think I've devised up a pretty solid plan to get it done. I've broken it down into 4 parts, and we're going to go through it in this video. So let's do it. Starting with step 0. The logic behind the plan. So a key trade-off I've decided to make in the construction of this plan is to kitify it as much as possible. James Wilmsley from Project Air has made a lot of progress and has learned a lot through kit builds, and now he's able to do a lot of things on his own, which is what I kind of want to emulate. Similarly, I learned a lot from my level 1 rocket, and that was also a kit build. And in general, I think getting away from the theory as quickly as possible and getting to application is the best way to drive home a concept. That's one of my main gripes I had of my degree, but I digress. Elon said something similar.
And then you want to teach to the problem instead of teaching the tools.
Now, there isn't a guided rocket kit, but if there was one, it would start by addressing the main hurdle you have to get over to build a guided rocket, which isn't the hardware, it's actually the control software, namely PID, proportional integral derivative controls. Now, I've heard that an LQR, a linear quadratic regulator, is actually a bit better, but I'm pretty sure you can get it done with just PID. Joe Barnard from BPS was able to do a lot of great stuff with just PID, so I think it's a good starting point. And then if I want to refine it further, I could do LQR later on. But we're just going to do PID initially. But as you probably know, rockets are expensive. So learning about PID, do ground testing or flight testing will get really expensive really fast. So I don't want to take that approach. Instead, I want to take an approach where I can iterate quickly and through that process gain a deeper understanding of PID. Hence, phase 1, the reaction wheel. Now, a reaction wheel is pretty simple, pretty straightforward. All the wheel has to do is spin to counteract its changing angular position. It's often used in space for precise positioning up there. And there have been a lot of attempts at this on YouTube. And in the spirit of the maker community, they've made a lot of their files public. So, again, in that kit build process, I'm not going to reinvent this process. I'm going to take what they've done and build off of that. Yeah, so I plan on using this one from this guy. It looks like a solid build, and I think I can build off of that. As you can see, I'm in the ordering parts stage. I'm still pretty early on, but we'll get there. I've broken up phase 1 into all these parts, ordering parts, then 3D printing the structure, wiring it all together, getting the readings, and then playing around with PID. And then once I'm finished with that, I'll complete a phase debrief. And the purpose of the phase debrief is just to make sure I understand what the hell I just did at this stage. So the key takeaway for the end of this phase is to have a really good understanding of PID. I need to be able to explain in depth what it is and how exactly it functions. I should also have gained experience soldering and working with electronics, especially with the MPU 6050, which is going to be a key component in the next phase. Phase 2, flight computer development and integration. So Joe Barnard from BPS has already created an incredible series walking through the steps for creating a flight computer. And as you can see from my plan, I've actually already finished ordering all the parts that I'm going to need for it, because I was thinking I was going to do this first, but then realizing I should probably go a step back so I could learn PID well. He's provided his Patreon support as the exact files, but in order to get out of tutorial hell and learn things, I decided to change it up just a little bit. So instead of using the microprocessor that he chose, I'm instead going with the Arduino Nano Every. It's a bit more powerful and a bit more modern. His project is like 6 years old at this point. And then instead of just using his PCB design, I decided to design mine from scratch. That way I can learn about reading data sheets and getting information off of them, as well as creating my own symbols and footprints and using PCB design software as well. These will all be good things going forward to learn. So that's why I'm doing this approach. I also have to mention that I am definitely using AI for help. I kind of view it as like a sensei, a really smart sensei helping me out along my journey. So whenever I get stuck, instead of going to Google and like searching for help there, I've been using like Claude and be like, hey, yo, I'm stuck here. What's going on? What am I not understanding? And it's helped me really quickly get past bottlenecks and quickly continue to advance. So highly recommend that. Again, I don't think you should rely on AI as a crutch, but I also don't think, especially in today's age, that you should avoid using it. So it's a tool that we can use, and I think it's appropriate to learn how to use the tool. So that's how I'm going about it. So after designing it, I'll print it, assemble it, and test it. Hopefully it doesn't explode. And then I can move on to assembling the airframe. Either find a 3D print test rocket body that I like online, or I'll just design it myself. It's just a cylinder, so it can't be that hard to build. And then again, the thrust vector control mount, also outsourcing that. Joe Barnard has a really great one that he used for his rocket, so I'll just be using that one as well. And then the final part of this phase will just be integrating all of that into the body, and then this phase will be completed. So the main learning takeaways from phase 2 will be learning how to read from a data sheet, learning how to design, layout, order, and assemble a PCB from scratch, and then getting more experience 3D printing and integrating separately produced 3D printed parts. Once I have a solid understanding of all of that, I can then produce to arguably the hardest phase, what I think will be the hardest phase, phase 3. Software development. Like you can see, my software development part is pretty light. I'm not entirely sure all that I'll need to get done, and this will probably have to add a lot more to this, but that's the plan for now. I'm honestly kind of tempted to see what will happen if I just let Claude or ChatGPT just write something up for me, and then I'll just throw it on the rocket and see what happens. Probably won't work, but I do plan to take the PID control from the reaction wheel, port that onto the flight computer, and then just see what happens. I'll bench test it with the thrust vector control mount and just see if as I move the rocket, will the thrust vector control mount move appropriately? And if it does, I might do a hot fire test with it. And if that goes well, I might just send it. But no, I highly doubt it'll go that smoothly. So I'll probably have to do the traditional route, which I think involves doing MATLAB simulations, testing out the PID gains through that. I think I have to write a state machine at some point, and a bunch of other stuff. Yeah, this one is kind of the question mark phase. I don't know what I don't know, which is why I tried to kidify things as much as possible. I want to get to this point ASAP, as I believe this part is the hardest part to getting a guided rocket to work, the controls. But yes, once I'm able to crack this part, I'll do bench tests, which is just checking to see if the thrust vector control mount is operating properly, and with that, phase 3 will be completed, and we can move on to phase 4. The key takeaways from this phase at this point, I think, will be learning how to, use simulations in MATLAB, learning how to write state machines, and then learning how to tune PID gains, all of that stuff. I think those will be the big learning takeaways from that phase. We'll see. With an understanding of PID, a flight controller built, and the software loaded onto it, there's only one step left. Time to test this thing and send it up, right? So phase 4 is ground and flight testing. At this point, we're going to be doing hot fire, hold down tests on the ground, and ideally those go well. And then from there, we'll begin flight testing. We'll complete our first flight test, which probably won't go according to plan, but we should get great data back. We'll take that data back, look at it, refine it, tune the PID gains further, and go from there. This phase will be completed once I'm able to complete 3 stable ascent flights to prove that, it wasn't just fluke. And if I can do that, then yeah, this stage is completed. The key learning takeaways I think I'll gain from this stage will be collecting and interpreting flight data. And with this phase completed, the entire project will be completed. So by this point, I'll have a solid understanding of PID control. I'll have gained more experience soldering and working with electronics. I'll have learned how to read data sheets and how to build a PCB from scratch. I'll have gained more experience 3D printing and integrating 3D printed parts. I'll have gained experience doing MATLAB simulations and writing state machines. And I'll also have gained experience conducting ground testing and flight testing. So a pretty good project, all things said. I'm not familiar with any of these things, so if I'm able to get this done, then I will have grown a lot as an engineer and added yet another project into my confidence and competence bank. A growing bank of projects is an important motivator to continue building more things, so I'd love to add this to the bank. Will everything go according to plan? Of course not. I'm looking forward to the videos to come explaining everything that went wrong, but it should be fun. So let's do it.